In the upcoming evolution of the Internet of Things and cloud computing, the abundance of data is enabling many transformative applications. However, with the pervasive and large-scale data collection, storage, sharing, and analysis, the technologies that have greatly improved our daily life is now threatening our fundamental civil rights to privacy. Due to the highly sensitive nature of private data, the problem of misuse is becoming ever more concerning to individuals. In the notorious Facebook Cambridge Analytica scandal, more than 87 million Facebook users' profiles were harvested without consent and used for illegal political purposes. This data misuse problem is rooted in the fact that individuals will have no control over how their private data will be used when shared with other parties. Meanwhile, existing access control mechanisms do not prevent second-hand data misuse. To address the misuse problem, we formulate a new privacy goal called data usage control. Individuals should have full control over how their private data can be used by whom and when. This reflects the contextual nature of privacy. According to recent privacy legislation, represented by European Union's GDPR, individuals should have control over how their data can be used, such as the right to restrict processing and the right to object. Here you may wonder, is the data misusage problem only solvable by legal mechanisms?
In this work, we present a technical solution, called PrivacyGuard, to prevent data misuse altogether and empower individual data owners with full control over both the access and usage of their private data by any data consumer. Such as who can use my data for which operation at what condition. The plaintext data should never be exposed to other parties. In the meantime, data consumers expect the operation to be executed correctly and receive the execution result. And the usage records should be non-repudiable and can be audited later. To further enable a secure and sustainable data economy, where data owners can benefit from consumers' usage, we define the concept of a data transaction. In the simplest form, the consumer starts a data transaction with payment and receives the result in the end. And the whole transaction is recorded in the contract. To realize the above objectives, PrivacyGuard employs two key technologies: blockchain smart contract and trusted execution environment. We use smart contracts for encoding the data owner's usage policy, enforcing the data transaction procedure, and keeping a non-repudiable record of usage history. We use TEE for enforcing the confidential off-chain execution of the data operation designated in the contract. This off-chain execution crucially enables confidentiality protection on private data and avoids costly on-chain computation. The operation is included in a secure container, known as a TEE enclave, which will execute the operation confidentially. An important functionality of TEE called remote attestation allows stakeholders such as the data owners and consumers to verify the integrity and authenticity of the enclave program, despite the lack of trust in the host platform in the cloud.
Putting everything together, PrivacyGuard is composed of two planes. The control plane consists of the smart contracts and data owners and consumers' blockchain identities. The data plane contains off-chain entities of the participants and an off-chain contract execution environment that instantiates a TEE enclave for the specified operation. The consumer starts a data transaction by invoking an owner's contract. Then the data owner's off-chain entity iData agent and the consumer server attest the TEE enclave, and each establishes a secure channel to the enclave. The enclave fetches the encrypted data and then the iData agent provisions the decryption key to the enclave. Then the enclave decrypts the data and executes the operation confidentially. At any point in the process, there is no exposure of the owner's plaintext data. Our system also enables wholesale data transactions with the new data broker entity, who represents a large number of data owners while achieving the same goal of usage control. There is one last thing: how to securely deliver the result to the consumer while concluding the data transaction at the same time.
In response, we developed a two-party commitment protocol to reach an atomic completion of the data transaction and result delivery. Essentially, the owner gets the payment and at the same time, the consumer gets the result. And the usage is recorded in the blockchain. The three objectives are either achieved together or aborted safely. This is secure against the collusion of any two parties. For more details, please walk by our poster or check out our paper published at European Symposium on Research in Computer Security 2020. Thanks for your attention.